Okay, so the question is valid Sudoku. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of the 9 3x3 sub boxes of the grid must contain the digit 1 to 9 without repetition. So let's just take this example. So what you need to do is that this entire row should not contain any duplicate values. So what we need to check is whether every single row contains duplicate values or not. So for checking the first row, see 5, 3 and 7 are 3 different values. No duplicate values are present. So this is valid. Coming to the second row, 1, 5, 9 and 6 contains no duplicate elements. So this is also valid. In such a way, we need to check all the rows and then also all the columns as well. For the 3x3 grid, we need to check if this particular grid has any duplicate elements or not. Here 3, 6, 5, 9 and 8 contains no duplicate element, so this is also valid. So when we will say that this is not valid, so suppose in this row 5 is here, then we can say that this row is not valid and the entire Sudoku is not valid. All we need to do is check that every single row has unique elements, every single column have unique elements, and every 3x3 box have unique elements. So our best friend for finding unique elements is obviously set here. So we will be using set. So now the question comes, how do we need to use it? What we can do is, we know that we have to traverse every single box here. That will be going to give us an n-square solution, we know that, but how can we optimize it in space? So what the solution here can be is, we know that the row number is 0, 1, 2, 3 and so on. We know that the column numbers are 0, 1, 2, 3 and so on. All we need to check is that 5 is in row 0. Now this will be present inside the set. If suppose 5 is somehow present here, when we will be traversing this, when we get to this 5, what we will have is 5 is in row 0 again. So when we found a duplicate element inside the set, then we can say that yes, the Sudoku is not valid. So let's try again how it will work. Let's suppose 1 here. So let's suppose 1 here. Okay, so 1 is in row 1. Okay, in the first row there is no other 1 present, so this is also valid. Let's take another example for, let's say here 8. So 8 is in row 6, like that, and no other value 8 is in row 6. Now let's go to columns. Let's take 6. Okay, so 6 is in column 1. Take another example, let's say 3. So 3 is in column 5. Let's take 9. So 9 is in column 8. So like this, we have to put everything inside a set. So this set will be of type string. It's the only way we can store this kind of statement here inside the set. We have to use a string value. Now rows are done, columns are done. What about the third condition, the boxes? Pay attention. So what we are doing here is we need to name every single box. Okay, so how we can name it? Let's suppose this is box 0, this is box 1, this is box 2, this is box 3, 4, 5, 6, 7 and 8. Now how do I tell that which cell is from which box? So what we are going to do is we are going to use a formula. So row values are i's and column values are j. Okay, so what we are doing is I by 3 whole multiplied by 3 plus j by 3. So how does this work? Let's suppose we are at 0 comma 0. Okay, so we need to find the box position of this particular cell. Okay, so 0 comma 0. Okay, I value is 0, j value is 0. Now if we put it into the formula, what will it get? 0 divided by 3 multiplied by 3 plus 0 divided by 3. 0 divided by 3 is 0 multiplied by 3 plus 0 divided by 3 is 0. Now 0 multiplied by 3 is 0 plus 0 is addend 0. As we remember that we named this particular box as 0 and we are getting a value of 0. Let's take another example here. Let's take this 6. Okay, so 6 is in which box? So this is 0, this is 1, this is 2, this is 3, this is 4. Okay, so we need 6 to be in the fourth box. Okay, so putting it to a formula, the coordinates of 6 is 3 and 4. So we know that I is equal to 3 and j is equal to 4. Okay, putting it into the formula, so 3 divided by 3 multiplied by 3 plus 4 divided by 3. Okay, so 3 divided by 3 is 1 multiplied by 3 plus 4 divided by 3 is converting it into integer, it's 1. Okay, so 1 multiplied by 3 is 3 plus 1 is 4. So we got that 6 is in the fourth box. Let's take just another example here. Let's take 9 here. Okay, 9 is at coordinate 8 comma 8, right? Okay, and we know that this is the 8th box, so we need 9 to be in the 8th box. So 8 divided by 3 multiplied by 3 plus 8 divided by 3. 8 divided by 3 converted into integer, it will be 2. Alright, multiplied by 3 plus 8 divided by 3 converted into integer, it's 2. So 2 multiplied by 3 is 6 plus 2 is equal to 8. So we got that 9 is in the 8th box. So in the same way, we saw that 5 is in box 0. We saw 6 is in box 4. 9 is in box 8. And in the same way, we can check that these strings should not be duplicate inside the set. So coming into the code, we use an unordered set of type string, name it as t. Then we'll use a for loop, starting from 0 to 9. We are hard coding 9 here. Then we use a nested loop j starting from 0 to 9. Now if the board of ij is not equal to the dot, then we use a string val as the current index, the board of ij, and we store it in the form of string using toString. Now we use a variable row key type string, then value plus in row toString of I. So I denoting the row number here and the value denoting the value. And now same we'll do for a column key, and the column value is j, and then a box key, and we forgot to name it as column in column. Then we have value in box to the formula that we decided, I divided by 3 multiplied by 3 plus j divided by 3. Then we'll insert every value in the set if it's not present. So if st.count is there of row key, column key, and box key, if it's present, then it's a duplicate value and will return false. Else we are going to insert the row key, then we'll insert the column key, and then finally the box key. If we are able to come out of the loop, then we say that it's a valid Sudoku. So the time complexity of this solution will be O of 9 square, as we have hard coded 9, so it comes to a constant time. And the space complexity will be 3 into the 9 square, that also comes to a constant time complexity.